Let's see. Okay, so let me go over some things that's going on. Um, the let's see. We've been doing. Let's see. Alex and Ted have been working on the disc Yagis development. One of the goals I think we're going to have in the organization is to maybe get a kit going for disc Yagis, 21 centimeter disc Yagis. Sounds like something we could sell and maybe just make the discs and the everything. And now we got a cheap Yagi that does 21 centimeters. The publication and video index, it's not on the web yet, but I posted it in the listserv. So if anybody needs to do research or wants to know where all the publications are, it's in Excel, so you can just do a sort and everything like that with it. If you want full access to the Dropbox where all the publications are at, then you got to go and buy that from the store. And Les is our store manager, by the way, if everybody didn't know. And let's see, other things going on. People have been talking about the A302 interferometer design. The 88302, I guess, is a multi-channel receiver, and they've been trying to make an interferometer with it. That's been on there. Wolfgang has been published. He's been published many times, but he's got a new publication based on their receipt of the FRBs that they've been doing. So it's a pretty distinguished publication they've been doing. I guess they've got 3 or 4 big antennas, and Wolfgang's Ostropeeler antennas at one of them, and they were able to get published on their joint venture on doing FRBs. Let's see. We've been getting a couple of students that are that the grant committee has been getting super SIDS for and things like that. We're getting a lot more U.S. participation from the grants, and a lot of these are science teachers that run a couple of schools. Sometimes they have one main science teacher that coordinates a couple of schools. So they're asking for super SIDS and stuff. So they've been giving them super SIDS. Then they've been asking for mentors, and a couple of people have been volunteering to mentor these science teachers to help them get data and stuff like that. So if you want to be a mentor, just let me know, and if we get a high school or something like that, or a university that needs a mentor and they happen to be in your area, maybe we can hook you guys up. We had a couple of flares on the December 31st. We had an X5 flare, which is one of the large flares. A couple M flares and a couple low X flares have happened this last month. So the sun's pretty active. If you've got a super SID, radio Jove, you can pick all that stuff up. Let's see. A couple of questions have been happening about converting the G5500 AZL rotor system, which is a AZL, to radio astronomy. Right now you get these ones, and it's usually for AMSATs. And there's been, how do I convert that to actually track in celestial coordinates? I've done one of those things, very rough way to do it with an Arduino. People have been working on those things on how to put together something that will cause that to happen. I put a journal article on how the interfaces work. Pretty simple interface with an Arduino. If you got the Arduino goes with little toggle relays. Will control toggle relays, and that controls the 5500 pretty easy. So anyway, we did get a silent key, Jove. who's done a number of articles. He passed away this last month. So we're going to, someone's already written a tribute we're going to put in the journal. So we'll have that in this next journal. Let's see. That's all I've got. Anybody got any, Les, you got anything about the story you want to say anything about?
Fortunately, the store has been fairly inactive, but the occasional new member with Dropbox. It's been a while since I've seen a scope in the box request.
Okay. I think a lot of people are starting to build their own.
Well, some people are smart enough to realize they can buy all the parts without our markup.
Yeah, well, that's okay. That's okay. That means we're teaching them.
Yeah.
All right.
I'm just wondering when somebody's going to say, "Well, can I get the full set of documentation?" No questions asked, and I've always given it to them before.
Yeah, that's fine. We're not here for the money. We're here to train. Okay, I'm gonna go to Robert, who's in Australia. I think he's in Australia right now, but he's our faraway guy. So go ahead, Robert. What do you got going on?
Well, good morning, everybody. It's 6 o'clock in the morning here in Australia. What I've done is, absolutely correct about the scope in a box. What I've done is I have a friend who lives up in the Blue Mountains outside of Sydney, and I've given him a scope in the box that I just bought. Instead of getting it from you guys, I just ordered everything from Amazon and other places, and it showed up. And what I did last observation weekend, I set him up on getting it up and running and showing him how to use it. And he will, in the next couple of weeks, put the antenna up and then hook it up and start getting data for us. Okay. My radio telescope isn't going because the whole back of the property here is torn up. Building a car port carport for my Porsche, and so that's all torn up, and nothing is working there. The observatory, the pier is being modified, so that'll go in the next week or so. I met up with Roger Heap and Michael Samirsky, and we plan to get the antenna out of Varuna, redo all the webbing in there to see if we can't make it work. And meanwhile, I'll see what I can do to put a feed in place for it. What else? Getting ready to middle of March to head off to San Francisco to get ready to go to Dallas for the total eclipse. Have to pull all of the spectrum, the high resolution spectrograph and all the H alpha telescopes and all that kind of stuff. Have to pull it all out of storage. So that's the reason to go to San Francisco early, is to get all that stuff out of storage because it's not here in Sydney. What else? Nothing else. But you're right about the sun being active. Lots of cool stuff going on there. So that's about it for me right now.
All right, and I did have a request from Bob, who's going to be running helping run the Western Conference. If you can potentially give a talk about solar eclipses at the conference.
I could dredge up what I did in India a couple of years ago.
Well, that's fine, and because they just wanted some kind of a solar eclipse expert that can give a quick talk, and we can hook you up with a time. It's after the eclipse or before the eclipse or whatever.
Let me know what you need, and we can work it out.
So sounds great. Sounds great. All right. Well, thank you very much. Let's see. Peter, you're on mute. Peter East. Yeah. There you go.
There. Hi, yeah, I haven't got much to report. I have received my ARRL antennas handbook, which I'm very pleased with. It's taken a while to get to the UK, but it arrived in pretty good order. I guess you've already got yours.
Oh, the antenna book.
The antenna book, yeah.
Yeah.
It's quite a weight, isn't it?
Yeah, it's large, and we got a pretty good write-up on that. So now, just to let you guys know, we've also been invited to write a radio astronomy section for the the engineering book for ARRL. And so I've already sent a notice out to the bunch of the authors, and they want less antenna, more system. The main editor wants to know how we pick up all this very minute signals with the receivers, which are fundamentally the ham radio guys use almost the same kind of receivers, but somehow they can't get all this low signal. And they wanted us to sort of concentrate on how we do that as radio astronomers using, RTL, SDRs, things like that. So we're going to grab all the different journal articles that relate to the entire system, software, and everything we use for radio astronomy. And we're going to put that in the big engineering book under radio astronomy. So they gave us a section there that we're going to put together. So just like the last one, it took a year from when we submitted about 100-page articles to when they got it down to about 20 pages and actually got the book out.
Yeah.
So we're just starting that process now, and I told the authors we're going to probably try to submit in the middle of February, a draft, so these guys can look at it and say, nah, it's not what we wanted. We want something different, or whatever. But they're definitely we're gonna have a large section, and then they're gonna knock it down to 20 pages or something. So,
Yeah.
But it's all good. We're getting a lot of publicity out of it, and a lot of the hams are seeing what we're doing, and I think we're getting it's good stuff. I'm sorry, Peter, I jumped in the middle of your
That's all right. We often on our TV we get adverts in the popping in at the sides, but no, that's great. Yeah, I'll try to do something and get it to you as quick as I can.
Right,
the weather in the UK is really awful at the moment. We've had a very cold spell where the temperature in places in the UK has gone down to about -13. We've had about -5. I'm in the south of the UK. So it hasn't been too bad here, but in Scotland, they've really been suffering. And we've got the ninth storm of the year that's planning to hit us tonight. So we might not have a roof tomorrow. We've not experienced weather like this for quite a while. But anyway, and so that's really stopped me getting my antennas out and doing a bit of outside work, which I'm desperate to do. But anyway, I'll keep.
Is that background picture real?
It was. That's something in the summer.
I was going to call you on that.
Were you? Yeah.
All right.
Yeah, so work-wise, I haven't done an awful lot. But
all right,
interested to hear what other people have got to say.
Okay. Let's see. Let me see if I can get. Let's see. Detlef, are you in Germany?
I'm sorry, my microphone was muted. Yes, hello, from Germany. Yes, I think I worked on the same time on the phase-coupled antennas, but I think I have no new things. First, I want to make some simulation. I work on it, so maybe in the next time I could show a few results.
That's great.
Mm-hmm.
Yeah, we'd love to see it.
Okay, thanks.
Okay, Franz, So I'm trying to get all the European guys and Franz, are you on? You're on mute.
Hi. For me, no news. Only what I can say is still working on the greenhouse, so that is a higher priority. But further, I have a lot of contact with Alex about the next steps. And really, Alex is mentoring me and sent me all kinds of information. So I do a lot of reading and I buy some basic stuff what recommended was by Alex for setting up the system at home. So I hope that I can start next month to building the system, and Alex offer to come and help me and checking and see if everything is okay and do the calibration so that I can serious work on the telescope.
Great. All right, thank you. Let's see. And Alex.
Good afternoon. I've been spending a lot of time on this disk Yagi, and there have been a few iterations since, well, certainly since last week or 2 weeks ago, and the Zoom meeting, and then I uploaded some items to the groups, Google group. If you look on there, there is some additional information, and I have about a half a dozen slides to show you on the current project and how it's developing.
Go for it.
So, a couple clicks. Do you see this?
Yes.
See, it says, please move away from it. Well, that didn't work. Hold on. Start over. Try. Screen. Said something about move away from the edge. Okay. So can you see this?
Yes.
All right. So initially I tried to design this based upon some information from some French amateur radio astronomers, and I didn't have a lot of success with that. And I found this engineering professor over in Slovenia, Dr. Vidmar, and he had a model. His models were for more amateur radio bands. One was 1.3 gig, 2.4, and 3.4 gigahertz. Anyhow, he had a good model, and I've used his model, but models are only that. But let's see if I can show you where I've gone with that. So based on that, I developed this. It's about 1.5 meters long, breaks in 2 sections. This 25 disc system, and it works really well. I was for its physical size and weight, it performs quite well. And in comparison to my 2-year effort on the what's now about a 1.2 meter dish, it's not that much different. It has a wider beam width, and I've got some specs that I can show you, but you know, that's not bad. And I turned that out in a few days, whereas the other one had been developing over a many months period. And I've also been working on this. This is the mini version. It's a 3/4 meter, 15 disc, and this is kind of the idea with kicking around that might be worth implementing into a kit. I'll show you how this compares to some of the other telescopes I built, and this looks promising. This still I don't think is tuned to optimally, but what I want to do is to try to tune it as well as can be, and then build one of these up without tuning and see how how well it performs. The disc Yagi and especially the patch feed is very precise. It doesn't allow a lot of fluctuation, changes in parameters, but that's what I want to see. That's where I am right now. This is from today. Reasonable signal, about average, about typical what you would see, but it certainly isn't down in the noise level for the size and complexity of the antenna. Okay, here's some comparisons. This is my system, and like I said, there's been a lot of effort put into this, and it works pretty well. This is the 2425 1.5 meter long patch Yagi, and down here, let's see, yeah, this is the mini. This is some data from today, so it's not performing all that bad. This is the 1 meter umbrella that I designed, and down here, this is the circular patch that I got from the French group. Never figured out how to tune that. There's a piece missing down here, and maybe someone can supply this to me sometime. Up here, here's some T-Sys performances. On my system, pointing it at the sky and then back down to the earth, getting a 7.2 dB differential. That's pretty good. The 1.5 meter circular patch is 5.9. The one I just been working on today and have it fairly well tuned, 5.5 dB differential. That's not bad. The original disc antenna didn't have that much, wasn't that bad in this earth to sky, but it had very poor reception. Down here is my umbrella, and here is one sample I have way back when from my Wi-Fi dish, unmodified. That's it. The beam width seemed to be wide. I did a sun drift scan, and it's looking like it's about 40 degrees. The model shows it to be 20. Issue I have is that I have a small backyard. There's the roof of the house interfering one side. There's trees on the other. This may be broadened by reflections off the roof or something. The plan is to go out into the field maybe next weekend or thereafter with a noise source and see if I can actually characterize this better than trying to do a sun drift. I've improved my method of making the disc. I can cut a stack of them, can turn them in groups, but this is still intensive. I'm not interested in cutting these discs for the directors. I did find a guy that said he would make these for $1 a piece. That's a bargain. There's a lot of work that goes into this. He can laser cut them. I think that's about the end. Yep, that's the story. Any questions? We're here?
Yeah, we're still here.
Okay, all right, no questions. The one thing that's missing from this, if someone has one of the standard scope in a box systems and could get some data from DEC plus 40 and RA 2030, the bright area of Cygnus, using SD Sharp and IF average, and send this to me, I'd like to add a spectrum to this collection. I've been running a 5-minute average. So in order to add it to this stack, it would be declination plus 40 degrees, rate ascension 20-30 hours thereabouts, and a 5-minute average. I'd like to add this to the data set. Thank you.
Okay, any questions?
Lovely work.
Thanks.
Yeah, and now the other person doing this is Ted.
That's my cue. Okay, here I am. Yes, neat stuff, Alex. I think that's great. You're working on making increasing gain that way, making the antenna big. I think that's exciting. I'm trying to study probably changing the bandwidth, the beam width, I'm sorry, looking at a smaller part of the sky. And I think both of these are neat directions to go explore. Let me try to do a little sharing and show you the tiny amount that I've been adding. Let's see, screen share, the big button. And then we got to go for, so many went, oh, this one, there we go. All right, I'm hoping you're seeing that. Let me turn this stuff off. So
there you go. There you go.
Here's my ad for Ezra. It's up there on the web. This is the software I've been using. Let me know how I can improve it. To review, this was the disc antenna, disc Yagi was the name I came up with. And you've seen this before. There's one of them sitting out there looking at the sky. I mounted it on a board. I can point at different directions. I mounted actually two of them on the sky. That's 2 meters apart. This is all old news. We've talked about this before. I think last time, I guess 2 weeks ago, sure enough, I put them closer together. That's 240 millimeters apart. So now we're within that wavelength area for separation. What happens and then the weather got nasty. And so I haven't been doing much. They've been working outside and I have not. That's okay with me. So I took a bunch of data, several days, and added them together to plot it on the sky. Over on the left-hand side, you can see that we've got some kind of drift scan of the sun going by. I did some math on it with 2 antennas there working together. I could come up with a measurement of maybe 11 degrees of a beam width for a half power beam width for a sun drift scan. If I measure it a slightly different way because it's such an irregular shape, I measure 17 degrees. So 11 or 17 for 2 antennas. Just for a name, I'm calling it EZ. Of course, everything has to be EZ. And then disc Yagi. So that, at least it's a different name than Alex's, so we can talk about them in the same paragraph with different names. Okay, that's 2 antennas. Does that give a smaller beam width on the sky than 1 antenna? Well, I got to turn one of them off. So I just unplugged it, and now I'm looking at 1 antenna. Here's for 1 day's worth. Here's half power between the max and the min. And how long is it? It seems to be about 126 minutes. For 15 degrees per hour, that would mean a half power beam width for one of these antennas is about 31 degrees. But that was only 1 day's antenna, 1 day's data. Let's get a couple of days. So that's why I was quiet. I was busy pushing buttons, getting for 2 days data now. And it's not a perfect shape we can see. But if we zoom in and draw it all up while I was, as you started the meeting, it looks like this time period is about 1.8 hours. At 15 degrees apiece, that would be about 27 degrees. So the screen before was 31 degrees with 1 day's data, and with essentially 2 days data, I've got 27 degrees. Okay, well, some consistency, that's good. If we take this 27 number, well, actually, yeah, so if we go back here, that's a nice round number, about 30 degrees, right? Compared to 2 antennas at maybe 17 degrees, yeah, there seems to be some hope for putting 2 antennas close to each other and getting a smaller beam width across the sky. in a cheap way. All right, that's what I want for drift scans of galactic hydrogen, some cheap way to get a small beam width across the sky. It's interesting, my beam width, so now we change it to a new topic. My beam width versus Alex's. Alex, you were saying 40 degrees, and here I was saying something like 30 degrees, 27, here's 31. The difference between our antennas may be tuning, sure, because I just put parts together. I haven't really looked at any kind of Smith chart on them.
Ted, I think he was doing FPVW instead of HPVW.
Ooh, Alex, is that true?
It's full.
Full power beam width. So what are we measuring there? Then the angle down here at the bottom?
Full width, half maximum. Full width, half maximum.
Okay. And
also,
so those are the same words as half power.
Beam width, but it's half power. It's not halfway to the noise level. It's half of the power. You're looking at your plot here. Let's say it's 80 peak. You have to measure it till it goes down to, 0.8 till it goes to 0.4. It's not halfway to the noise level. It's half of the power. Let me show you a slide.
Yeah, because the noise is providing power there. I'll have to study that. I don't know that. And so that indeed may be the difference between our numbers. So that's good. Now we got something to pursue. Why would you have 40 and I would have 30? Excellent. Thank you.
I'll show you what I did.
Yes, and I will. I guess my concluding point would be that at least I'm measuring consistently, so I'm getting less beam width with two antennas than one, and so that's encouraging. Yeah, let's make some cheap antennas and have folks explore that stuff. Thanks very much.
Sorry, one question.
Alex, a question then,
yes.
while I still have the slides up.
No problem. How do you combine the two antennas? By a coupler, or do you have two receivers or one receiver and to add only the signals from the antenna?
Oh, no. This is very cheap stuff. I take the two coaxes and the coax that goes off to the SDR, and I short them together. I take the shields on the outside and connect them, and thanks. I take the centers to connect her. So that's not very clean.
Oh, it's a good idea. Sorry, thanks.
But it was quick, and it also allowed me to keep sending power all the way up to the two LNAs way up here in the snow.
Okay, it works. Thanks.
There should be a nice combiner in there, and mine is simply just connecting them together. Other questions quickly?
I have a comment on that. Supposing you take the antenna feed and optimize it so that you can do the direct combination. In other words, you change the impedance of the feed point so that they all match into 50 ohms.
What you're talking about is changing the radius up here.
You change that to be 100 ohms.
Yeah, but I have an amplifier in here, so I don't think it matters.
You're right, it doesn't.
So the amplifier wants 50 ohms, and
never mind.
I think this is something like 50 ohms.
Never mind, but they're so close together, you can get by with one amplifier and a Y connection.
Yeah, that's something I can now study. I didn't think I could do that at 2 meters, and I was just moving those parts around.
Yeah, right. Okay, never mind.
Okay, let me unshare out of here. And Alex, you wanted to show some things.
Oh, go ahead.
Just one slide. Let me see if I can do this.
And this had to do with proper measurements here. That's good.
All right, so the half power is half power. It's the 3 dB down point. So this is minus 57.5, so it should be down here around 60.
Your screen just turned into a whole lot of black. If you push a button, we got a window on top. Oh, that's a little bit better, but now we got a black band. It's almost like we need a screen refresh.
No, it's probably need a internet refresh. I'm not even sure I'm online right now.
Yeah,
I say
you
this
are.
because you were waving your cursor around and we couldn't see it.
Yeah, just try share and reshare.
Okay.
Yeah, I think that's how you measure a half power beam width is a good question, because you guys are totally doing it different.
The beam width
Am I? Okay. Yeah.
half power is should be 3 dB down. So there's 1, 2, 3. And so this is the okay. It's half power. If in dB, it's a 3 dB down. So this is 57.5, 58, 59, and 60.
Right, and I'm going halfway between the noise background and the highest peak.
And the fallacy in that is the lower the performance of the antenna, the narrower the beam width you get, because of the higher the noise level. Anyhow, this is the way to do it. And so this comes up around 17, so maybe it's 38 degrees, and I rounded it off because you're getting a slope, you're getting influence from the ground noise pickup. So I picked some tangent points off of there, but that's the definition full width half.
Very good. I'm going to study that. All right.
Hey Ted, since we got Ray from the DSES organization on, and they were going to put a interferometer together with I think some large dishes. Can you talk about what you found about the distance between for hydrogen, the distance between the antennas, and how farther isn't necessarily better?
You're talking to me like an expert. I
mean, you did that study, and you're saying if I put these, if I measure 21 centimeters and I put them together, I put them, X number of meters apart, then it's right. Actually for at least for galactic hydrogen is not good.
The DSES antennas are wide apart. At least one of them is in cement, right? And I'm concerned that that's quite a spacing we're going to have. It would be, because what we want to do is be like the very large array and have them wide apart and get good results. But what we're going to do is find there's a tiny little spike in the middle. And if you go too far, I don't think that we could even see the spike. And it all depends on wavelength and which frequency you're using and stuff like that. But we're going to have a bunch of learning, and that's okay too. We're going to have dishes that will, a second dish out there at Haswell that will have motor control and things like that, even if we use it independently. And so that's cool. But what we may find is for the at least galactic hydrogen frequency, that those will be wide apart. The other concern, I guess Alex and I have been learning, that a galactic hydrogen source out there is a cloud. It's not a dot. And so we're going to find that our interferometers just aren't very meaningful to find a single source out there. We might see a blob go up and down, but I'm not sure we can even do that. So for galactic hydrogen, I'm not sure that spacing is helpful at 1420. So yeah, let's talk about that offline a bunch.
Yeah. So I think you see like Casse or something like that, but not the clouds.
Correct. A point source will work better with interferometry, and we're seeing that on the listserv for results. Yeah.
All right. Okay. Hey, any questions for Ted? How about an easy RA questions or anything like that too? All right. And
keep the comments coming. This is good.
And by the way, Alex, just to let everybody know, what is the software you're using to process yours? I think it's MATLAB or something, right?
Hold on, I was making some coffee. The the individual graphs, I just plot them in Excel, and for the comparison of amplitudes, I find that to be a very easy, straightforward way of comparing. The only thing that's weird about them is that you have to convert it to dB, 20 times the log of 10 of the numbers that the IF average generates, and individually offset that whole block by some amount. Let's like maybe have to add maybe 85 dB to the whole column to shift it back so that the cold sky background equals 0 dB. And then you can see what the signal is above that. And the other maps, yeah, I wrote that in that letter. And
you're using a standard RTL SDR with a like a Newelec LNA kind of thing?
Well, the stuff you saw today, yes. On my 1.2 meter, I have some Tom Henderson stuff, W5ADO, LNA, and cavity filter and secondary amp. But all of these disc Yagis run the Newelec LNA, and I use an AirSpy Mini. Has 12-bit resolution. You're going to be splitting hairs. It's going to provide an improvement, reduces quantization noise. I've never compared it, but for 99%, yeah, you can use all the Newelec stuff.
All right, great. All right, any questions on either of these two guys about how they actually took measurements and stuff? All right. Preston.
Okay. I really don't have anything to report. I've started teaching again, so busy.
Good. What are you teaching?
Earth science. We're going to have an astronomy field trip, and then I'm teaching geology.
All right. I wonder if you need a superset or something for your okay. Let's see. We got Tom on. Tom, any details about grants or anything else you're doing there? I've caught him off guard here. Oh, I may have got him off guard. Okay, let's get somebody else and he'll come back on. Let's see. Ed.
Oh, wrapping up work here, looking at retiring here sometime in April. So hopefully I'll be able to get my health under control, my back, and hopefully be able to get started on getting some things done.
All right. And you get to your real job is doing radio astronomy instead of that old pesky work stuff.
You got it.
Yeah, I get it. All right. Thanks. Helen.
Hi, everyone. No, I've been working on Dr. Klein's Easy RA, and that is just fascinating. I'm learning a lot. I'm to you gentlemen, I'm basically in kindergarten, but I am learning a lot, and I really appreciate that website. That was an awful lot of work putting it all together, and it's been really helpful in giving me a basis.
All right. Okay, thanks.
Thank you.
Don Latham.
Howdy. Nothing really new. I'm investigating how to hook my antenna controllers and stuff together, trying to look at MQTT instead of trying to write a broker program for RS-232, which I was faced with doing. So MQTT is a message broker system that I think will do most of the work for distributing controller information around using my wired internet. So that's where I'm at now, trying to cover another new thing.
All right. Okay. Any questions for Don? All right. Richard Flagg. All right. Caught him off guard too. Let's see. Monroe.
I am very appreciative of what you guys do. We didn't even start the session and I already started getting the information I was looking for. Loved the ELF anecdote about the antenna and the seagulls because I'm looking into doing some ELF. But the most valuable thing was the G5500 and PSI rotator because I was looking for a heavier outdoor full-time mount and rotator. And that one seems to be hitting the spot. I've already found the user manual for it and the PSIrotator information. So thank you very much. But that's it for me.
Yeah, I've had mine for 10 years up on a pole, and it is so reliable. I've never had any problem with the rotator. And I've put different antennas on, different size antennas, and I've never had any problem with the rotator whatsoever. So it's very, very durable, the 5500.
Yeah, and I think it's interesting that they use a DC voltage output to indicate the current position of the antenna.
Yeah, it's a very simple analog output that you get for your AZL, and you just have to, calibrate it a little bit, but it's easy to calibrate. And
Yep.
So
I would be looking at, if I get one and started working with it, I'd hook it into the ND library so that then I could use any astronomy software sort of off the shelf that talks to ND and it could position the antenna.
Yeah, if you find that, I'd like you to, if you actually get that working, because I think that my problem was I had to put an Arduino with different software in it, and that was pretty painful, but it worked. But I've not found a commercial software yet that talks directly to the 5500, which would be nice to have.
Jim, PSIrotator has hooks built into Jim Sky's antenna stuff too, or Jim Sky's what am I trying to say? Radio telescope programs. You just hook them up.
Oh, that'd be nice.
Yeah, it's a feature in the, get a hold of the PSIrotator handbook and have a hard look at it. That guy works his behind off taking care of this program. That's why I really like it. It's well maintained, has a large user base. It has a IO forum, much like ours, only larger, and it's very active. I recommend it highly. It's a good piece of stuff. You have to work at it. It's going to be like Easy, the famed Easy. It might wind up not being so easy, but on the other hand, it's a really useful rotator tool.
Yeah, I'll definitely take a look at it.
Yeah.
You got a link to that there, Don?
No, I don't have it handy. Sorry, but all you have to do is go to your thing and put in PST Rotator, ROTATOR, and you'll find it right away.
Yeah, it's PSIrotator, and if you just Google search the contiguous string PSIrotator, you'll find it on the first try.
Yeah, it comes up right away.
Yeah.
All right. Excellent. All right. Did we get Tom or Richard online yet? Okay. Monroe. Joseph Sandy. Like you're a new guy?
Yeah, fairly new. This is the second meeting that I've joined, and I recently joined Sarah too, so that's fun. Let's see, I can turn this on.
Good.
And I
Hey,
can wave. And if I can do a quick screen share, I think it'll
Yep.
work. I worked with Ted last night, and we got a antenna setup going in my backyard here. So that's fun. Just shy of 24 hours running now, and I'm using his Ezra software. So that's really fun. This is all still like effectively Greek to me. I don't know what any of it means, but that's why I'm here, is to just get to learn more. So, and that's pretty much it. That's all I've got for right now. Just a new member.
well, tell us what your setup is. Your antenna and your receivers and LNA.
I think that Ted would have a better chance of doing that because I got all the equipment from him. I know it's the new Elec is the little USB receiver. I'll just let Ted go because again, most of this stuff actually is his. I'm just borrowing it for the time being.
Joe, share that again, and we'll point at stuff.
Hold on.
Give us the live screen. That'd be great.
Which one? The one with the computer or the one with the?
The second one you showed us, which is live easy call.
That's this one.
So he has lots of computer power, and so he's actually showing you live the easy call, meaning collector program screen. And he is collecting reference samples from 1423. It says so way up in the top right-hand corner for a frequency control center reference at 1423, which is supposed to be a place where there's no hydrogen. And so we're comparing 1420, the next line down, to 1423. Now, these are all relative measurements. There's nothing particularly absolute. But between those two spectrums, there's a bump in the middle. So the antenna signal is getting something that the reference is not and putting kind of a little bump in it. There is a slope to the whole line, and that has more to do with the reference, the frequency response between those two nearby frequency spans. But okay. And the big wide bands of red, green, and blue simply show oscillating from the antenna average signal to the reference average signal, and back and forth and back and forth, up and down and up and down. It's kind of interesting that an hour ago, on the very bottom right in red, you had a peaker signal. I wonder if it just got colder outside there for a while. Kind of interesting. And there was a spike somewhere around about 3 hours ago in red down on the bottom. But otherwise, kind of interesting. But anyway, he's getting hydrogen there in the middle, and it would be interesting to see what it looks like when you process the data. As far as the hardware that I loaned him, yeah, it's just the NoElec stuff. I used, I handed him a H1 Plus, is that what it is? The LNA. This one's actually the one in the can, so it's all wrapped up, not the bare bones version. And then he's got the little SDR dongle, which is just the Smart T, which is so convenient because it sends 4.5 volts down the coax over to the amplifier. And show us the picture again there, Joe.
Let me see if I can grab it. Here it is.
It's not elegant, but it's out there in the backyard, just pointing to the south with something that doesn't move. We found a great big heavy tripod and bolted a stake to it and played with wrenches. In the box is Joe's laptop, just kind of grinding away with a power cord going to it. And Joe, you're just getting the data by Wi-Fi, right?
Yes. Yeah, it's just like set up to Wi-Fi, and then I can sit inside where it's warm and look at it from my computer. And then I also do all the processing on my desktop so that I'm not hitting the collection PC any more than I need to. So, and I was playing with that earlier too, with running some of the stuff and just looking at how it changed from yesterday. So that was fun.
It looks optimistic, but we need a little time to capture data.
Yeah.
Excellent. So you can too, Wendy. Come on, let's go. Let's hook up an antenna. And Wendy, I'm no doctor. I have no PhD. I got a master's. That's as far as I went. That's my news.
Cool. I'll open the floor back up for the next person then.
All right, any questions for Joe? All right. Hey, excellent work. Can't wait to see the results. Let's see. Monroe Joe. James Thompson.
Hello, can you hear me?
Yes.
Good. I've been doing nothing. So I've got no projects going on right now. Just kind of waiting for spring. It's kind of cold outside, so and snowy here in the Pittsburgh area.
Oh yeah.
So that's kind of what I'm waiting for. Spring.
All right. Okay, thanks. I haven't. Glad you're there.
Yeah.
Dave Lacko. No, I caught him off guard too. Jameson.
Hey everybody, what's going on? Let's see what projects we have going right now. I've installed Visual Studio because I want to take a stab at trying to improve IF average. I'm not a .NET developer, but I think I can give it my best college try. I've also been fiddling around with the Easy RA Ezra stuff, and I want to say a big thank you to Ted Klein because he helped me. Can I do a very quick screen share here?
Yep.
All right, give me 1 second. So this is just an image from that I had gathered with some with a simple 60 centimeter by 1 meter antenna, and I still had all that data lying around. And what was kind of intriguing to me is that the Ezra programs can slurp in that data that was gathered with SDR sharp, and you can do stuff with it like plot the spiral arms of the galaxy. So Ted really helped me out a lot. He did some of the processing because I didn't quite have my head around the workflow and was having some difficulties. But he was able to pull in the stuff to Ezra and get some nice, pretty graphs. And this is the one that I think is just way cool. This is with my old data. I did drift scans separated by about 10 degrees from 90 degrees declination down to about 10 degrees declination. Below that, I was starting to hit trees and whatnot. But with that old data, I was able to see, two of the spiral arms, the Perseus arm and the outer arm. And that's just really cool. So, Ted, I'm going to be taking you up on your offer to pick your brains a little bit because I want to understand exactly how this works. I've got some people in our astronomy club at work who are pretty intrigued by this. And I was like, I don't understand it well enough to understand all the ins and outs so I can explain it. But this is what this kind of software does. And it is possible with a little dish to, detect, to map out the shape of the galaxy. So, again, Ted, thank you very much. You have some very cool software that you put together, and I very much appreciate all your help. And I will be talking with you some more soon.
Excellent. Let's do that. If you can share, can you show us the right ascension declination picture? You showed us the one you made with Excel in black and white.
Yep.
And then there was indeed another one. What would it be?
Well, what do you want to do about it?
All right, so this is the one that I made in Excel. It's kind of blocky and so on, but I was happy to even see there's the Milky Way.
That's excitement. Oh yeah, I think so.
Some blobs of gas sticking up above and below the galaxy. I couldn't get down to the galactic center. That was a little too far south from what I could see. The power company has taken out a few trees since I did some of these drift scans, so I might be able to get a little further south. I'm hoping so. And I think that's my antenna basically. I haven't I followed the RTL SDR article on how to do a quick and easy hydrogen line thing, and so that will look very familiar to anybody who's read that article because I basically did what they said, and I weatherproofed my low noise amplifier. I'm using the Sawbird H1 Plus, and it's in that black box just below the dish. And then I ran a coax cable across the yard. We used to have Comcast cable, and they punched a hole in our wall with coax. So I just hooked up to that and ran this to my computer. I've got a little all-in-one PC that just sits there and slurps down data, and I can do astronomy from the relative warmth of my basement.
Now, if you just turn that antenna over that's next to it there, you'd have a pretty good sized dish.
Oh, you're talking about the geodome?
You betcha. You make a spherical feed like Arecibo and line that with chicken wire, and Bob's your uncle. I'm serious.
I will run that past my wife. I think the answer is I know what the answer is gonna be.
Oh,
but
was she grow peonies on it or something?
Well, I have a friend who has one of these 7 or 8 foot dish. It's like a satellite dish, and it's in his mom's yard, and she wanted to get rid of it. I have dibs on it, but I don't really have any place good to put it. But it's humongous. It's like I'm a pretty tall guy, and it's bigger across than I am tall. So I'm figuring 7 to 8 feet.
Yep, that's the one you want.
Yeah, that would have much better, I guess, narrower beam width and far better gain than this little thing. But I'm pleased with the results I got for a pretty minimal investment, and I'm intrigued by the fact that you can make almost no investment at all, and the disc antennas and even just taking one of those PVC pipes from Home Depot and zip tying pieces of copper, and you can map the galaxy with something that simple, which was True enough. Ted had in the video. That's wild.
Jameson,
yes,
for you.
Sure.
First one is less complex. How about grabbing some data at Deck 40 RA 2030 sometime for me, using SDR sharp and IF average, and set it up so you're capturing about 5 minutes of data per sample. That's probably around 800,000 samples.
All right, let me jot this down. So Deck 40.
Deck 40, and sweep through, maybe go from like RA 19 to RA 22 or something like that.
Okay.
And 5 minutes a sample. So have to figure it out. It's around, for me, it's like 870,000 samples. It's 5 minutes, but 5 minutes of data. And that way I can get, were you here when I was showing my presentation, set of plots?
I was here for the first time 2 weeks ago at the observation party.
No, like earlier today.
Oh, yeah.
Okay, because I'd like to add that plot, that graph to that set that I had presented before. Early on, I changed out my, like within a few weeks of getting the initial Wi-Fi, I swapped it out for my loop feed. I did things backwards. Anyhow, so I don't have any data from the true scope in the box configuration. I'd like to get that.
Okay.
Secondly, a Visual Studio. Do you have Daniel Kaminsky's IF average program? Because I do.
Yes, I sent the source to him, or the link that you had.
Okay. The other thing is I've been out, Daniel Kaminsky from Poland, University of Madame Curie University in Poland, wrote the stuff. I've been after him for 2 years to update it. It just hasn't happened. I have a list of ideas for improvement. So if I can somehow get your email, I'll send these to you. Give you an idea of what my thoughts are on improving as far as display and saving. So that might be.
Alex, let me forward my email.
You have those
I sent to Jameson.
Do that offline. Just do that offline, Ted. Send me his email and I'll connect with him sometime.
Yeah, okay. Right. You forwarded some suggestions to me, Alex, and I forwarded them to Jameson. Let me connect you two guys by email.
Definitely, that'd be great. So that's pretty much all I've got.
Wow, excellent work. Great job.
I'd like to screen share if I could.
Go for it, Ted.
If I can find the right picture now. So many pictures. Okay, I'm hoping that's coming up. This was his picture he just showed you, but it's fun that his data came up with all kinds of other nice stuff. If you take those bands and turn them into color, that looks nice. But if you had the computer interpolate between the points, it fills it out a little bit more. Color is always nice, but this is the same information shifted a little bit from his black and white picture. And then Ezra can go on and plot all this stuff up on the sky as well in galactic coordinates, and then even pretty round Mulvady coordinates. And sure enough, his data is right across the galactic center where the galactic plane is, confirming that this looks real nice. So hooray for Jameson collecting all this neat data with the old IF average method. The article was actually quick and easy. I'm sorry, no, cheap and easy, not quick and easy.
Yeah, it was pretty cheap. But yeah,
Well,
thank you for all your help, because I feel like I've been sipping from the fire hose since I started down this path, and I still have a lot to learn.
It is a big fire hose. It goes on
Yes.
for a long time. Exactly. There's lots to learn real quickly here. And then you go back and review it again, and it makes sense more on the 5th time. So good luck. Thanks.
Well, super good stuff. Did we get Richard Flagg back on yet? No, let's see. Dave, did you have something? Got it online here. Let's see.
Are you there, Rich? Can you hear
I'm
me?
here. Yeah.
All right. This is Dave Lacko. And I've been doing some radio Jove work. I had my antennas up a couple days before Christmas, all the way to January 8th. I'm using a pair of folded dipole antennas at 15 feet. And I did record the X5 flare, which is the data's up in the Radio Jove data archive. I have a question for the group. With the folded dipoles, I went from the bare wire to a pair of folded dipoles, and I'm thinking to turn them into a set of terminated folded dipoles. And I'm looking to get a little bit better sensitivity, and would that work? And that's all I've been doing. So any comments?
All right. Anybody know anything about that?
Yep, I do. Let me put the microphone on. A terminated folded dipole, you trade sensitivity for bandwidth. So I wouldn't think that would be the great idea.
Okay. All right. Because with the reason I'm looking for better sensitivity is for the Jupiter signals, because those are a little harder for me to get with the folded dipole.
What does your receiver noise floor look like before you connect the antenna? What's the delta between antenna on and antenna off?
It's really low because my setup is basically in the middle of a pine forest, and the whole county only has about 1,500 people in the county. So I have really no RF problems out there. So it's pretty low. When I tune my Radio Jove,
define pretty low.
Yeah, when I calibrate my Radio Jove, I'm right about 40 kilokelvin for my floor.
So what's in terms of dB, what's the difference between antenna and no antenna?
I haven't checked that.
My suspicion would be that you need to work on the receiver itself, its noise figure.
Okay, because I'm using the SDR Play RSP1A or A1, and I also use the Radio Jove 1.1 receiver.
I'm not familiar with the Radio Jove receiver, but my suspicion is that one of these relatively cheap preamps from China would do you good. And I've got more of these amplifiers lying around here than I know what to do with. So drop me a note, W8YCM.
Okay.
And I'll see if I can get something out to you.
All right. Thanks. And that's it, Rich.
Great. Do you got any pictures of your of that X5 flare?
Not it's on the Radio Jove data site. So if you just type in LACO, it'll pop up. That's on my laptop and I'm on my iPad.
Do you got a link to the Radio Jove site for people?
I believe it's just radiojove.org. It's the NASA Radio Jove homepage.
Okay.
And if they just go on the data archive tab and just type my last name, you'll see some of the Jupiter signals that I got, some IOA and IOC signals, and the X5 flare, both in the just at 20.1 megahertz, and then the the spectrograph data also is up there.
Great. And then Nathan just put the link in the chat for that.
Okay.
So great. And thank you. And Richard, did you just come on? Is your Mr. Radio Jove? Are you there? I can't hear you. Oh, I'm not hearing you, Richard. So Richard Flagg. Okay. Well,
all right.
We can't hear him. So thanks, Dave. Good work.
All right. Thanks, Rich.
All right. Let's see. Colin. Okay. Are you up? You online, Colin? Okay. Ed and Gladys.
Hi, I hope you can hear me.
Yep.
We are planning to come to the Western Conference. We already have our reservations, hotel reservations. And by the way, there are about 6 or 7 more rooms in the hotel that's mentioned on the website, just for other people to know. This is the conference out in Dallas with the solar eclipse. I found an article in the Journal of the Royal Astronomical Society of Canada. Not sure it's fully applicable yet to this level of radio astronomy, but they're basically doing detecting exoplanets with radio and using a new methodology. And I thought that people would be interested in that. And that's it. We'll see some of you out in Dallas.
Hey, Ed, don't tease us. You just said there's a new method and you didn't tell us what it was.
Excuse me?
you're teasing us with a new method, but you didn't say what it was.
I put it in the chat. So it's
okay.
It's in the chat.
Well, explain it a little bit.
Okay, well, basically they are using extremely accurate frequency and millisecond timing. And then, of course, you have to wait for days or weeks for the thing to rotate into a new position. And you do this by tracking the star. And it basically uses what would be redshift type technology, but in the radio spectrum to determine the type, the size of a planet. And it's an interesting article.
Okay, great. Well, that'd be fun.
So does the local time base have to be?
Well, there's a guy named John Ackerman who's working with Tapper, and he's developing almost a stratum 0. It's a stratum 1 time clock that uses GPS, and that is that's the type of accuracy that you would need in order to do this.
I know Ackerman well. We call them the time nuts.
Right, exactly. And John, I know John through Tapper because I've been in Tapper for many years.
All right.
The real issue is how good a crystal oscillator you start with, how much money he puts into it. So I'll look forward to seeing that.
Okay. All right. Any questions for Ed? Okay. And a guy I know personally, Bob Haggard, if anybody wants to know anything about model trains, he's the guy. But what's going on, Ed or Bob? I think you're on mute, Bob. All right. Well, I think I lost Bob.
How about now?
Oh, they're perfect.
Okay. Yeah. And like I said, this is the first time I've checked in here, and I'm looking forward to being getting more involved with this and such. I did have a little bit of experience with Radio Jove, but it never went very far because with DSES we got, as you know, onto a lot of other things that we're doing and such. But I plan on being here from now on for quite a while, Rich.
Great. And Bob was with me when we first got our first pulsar, along with Ray Uberek at the DSES site in Haswell. So he's infamous at the DSES group.
Yeah.
All right. Thanks, Bob. Nathan.
Trying to find the button.
There you go.
Hey guys. So got lots of irons in the fire on top of work and everything. Just got my new scope still sitting out there taking scan data right now for galactic hydrogen. Got about 3 weeks under its belt, so about 10 degrees of declination scan so far. So just kind of slowly letting the world turn. Outside of that, I've been doing some work with Steve Zickus, I believe is how you pronounce it.
Right.
I got in touch with him reviewing information in the analytical section. And so I got in touch with him and got signed up for the 20 meter program. And right now I'm working on methods of plotting data with some easier methods, and it might be something we can roll into. Need to figure out which screen is which. Screen one. rolling into other products like Ezra and stuff. So I'm hoping you can see my screen now.
You got something over it.
Oh, is it that? What is
Yeah,
it?
you got like a mini screen on top of it of your picture.
Let's see here. Are you able to see that?
Yeah, you got a double screen going there. Okay, yeah, zoom in a little bit on that one then. Okay, there you go. Contour plot of Green Bank radio telescope data.
Yeah, so
okay.
A couple of years ago, Steve did a demonstration of the 20-meter data collection. Saw a bunch of people in there, and this is actually some data that Alex was working with Steve to pull during that little YouTube video. And so I've taken that data, and now I'm starting to teach myself how to plot this in methods that maybe a little bit easier. And getting some of the contour data, the color plots, and everything like that. This has been a real stretch for my programming skills, which are minimal at best. So it's kind of promising results. It's not the best. This is the data that I'm working with here. You can probably see these FITS images now. So working with that, got some good ideas with Ted. Maybe we can roll this into Ezra and use it to keep making some improvements in the overall amateur astronomy for analysis and everything. So just kind of chugging along on projects like these.
Wow, good. Ted, is that something that Ezra pulls in, or are you going to have to do something new?
This is hours old, so this is exciting.
Yeah.
Nathan was playing with software, and you can see in the bottom right hand, he's got 4 images to start to match what the FITS shows from the GB20 website to show his data. So I think that's exciting. Nathan was getting essentially 4 columns of data, right ascension, declination, maybe the time and some power stuff. And what can he do with it? And so he started doing things like Ezra does and trying to pull it in and plot it. And here he is showing contour levels. I think that's exciting. So yes, is there some way to make a converter? You know, I got converters for all kinds of data. Here's data in a file from the Green Bank 20 meter. How can you now convert it into Ezra format to push it through that system and touch it, you know, and get your hands on it and play with the software and tweak it to your advantage. Ezra right now doesn't zoom in on the sky, and so this is a portion of the sky, and I've long thought about how to do that. It's just a matter of priorities. I did it years ago for another STEM project, and so yeah, this would be cool. Let's convert that telescope data too.
Yeah, and it's really handy because, you know, with using the Python and whatever, you can just pull it directly from any website, and so all their data is kept just in a straight text file on the website. So you can just pull any of this data. So you just give it a link, download it, process it, and plot it. It can be done in just seconds now. So
now with that screen up, sure, we understand time, right ascension, declination, azimuth, elevation. That's great. Now we can start plotting all kinds of things. But again, tell us what this 1 and 2 is, and what's an X and a Y.
Yeah, so I need to go back and make sure that I'm educated properly in this, which I'll be working with Steve quite a bit on this to really wrap my head around it. But the X and the Y's are 2 different polarizations in the 20 meter, and then it's actually measuring, I believe, 2 different frequencies. So this X1, Y1, that's vertical and horizontal polarization for frequency 1, and then X2, Y2 is horizontal and vertical for the second frequency. And then it also takes in if it's using that data for calibration purposes. So then I can, you know, then we have other options on how to calibrate this data, clean it up a little bit. One thing that that Steve mentioned in the talk online was this kind of I'm gonna call it distortion, diffraction, whatever, because the direction that the telescope is sweeping can sometimes looks like it kind of smears the data, drags it across in the right ascension a little bit. So how do we get that to line it all back up and put it all back into its correct home? So that's
Yeah.
gonna
Now,
be
what
some of
is
the
that?
stuff.
Is that a drag of the gears that your encoders are clockwise instead of counterclockwise, and they're getting confused, or is that something having to do with amplifiers?
I I'm not 100% sure. My intuition tells me it's just the fact that the the point is moving to the right and the telescope is moving to the left. So it's got a higher speed in one direction, relatively speaking, than it does in the opposite direction. And you can see
Okay,
that with
so you're
these.
saying the Earth's rotation is messing things up.
Yeah, well, it's the combination of the two, right? So as long as you can, if you just stay on that one point, then you don't have a problem. But it's because this is doing sweeps, because that little circle there is the size of the beam width. So it's having to do several different sweeps, about 10 or 12 sweeps. So as it sweeps to the left, the sky is rotating right, which makes the relative velocity higher in one direction than the other.
I'm not sure that explains it, because in
I
theory
don't know either.
it did the calculation for the right ascension and stuff correctly. And
Yeah.
so, all right, well, we can study this, but yeah, let's make a translator and then just push it right through Ezra. Says I, Mr. Ezra. I encourage all kinds of participation and exploration in every way.
Do you know that there's a NASA reader for that stuff?
A NASA reader?
Yeah, let me see if I can find it. I downloaded it. Yeah, you can process that. You can read those FITS files in. Let me see if I can find it. Hold on.
Oh yeah, well, the FITS files just have data, sure. But
I mean, you can read them and plot them. Let me see if I can find it.
I guess it's kind of nice to get the other two columns as well, and maybe the time. That's enough data in that table he showed to go straight into Ezra. That would be great.
The only disadvantage of that is those files are like radiometer data. There's no spectrum.
They have that in there too as well. So they have a separate calibrated spectral data.
It's just from one. You do not get, if you don't get a spectrum from that whole block of data.
Well,
Not
I don't
from
know.
one
I
whole
see
block.
I see megahertz on the left-hand side showing there.
Yeah, it's got the first frequency and the horizontal and vertical polarization there, and then the frequency 2 with its polarization. So you're getting the power from each side.
And so you're saying this file is much longer then?
Yeah, it's quite a bit longer.
And yet you're able to scroll it. So it makes me think it's not. Well, maybe, I guess you're sliding. So yeah, maybe there is lots and lots of data, and the frequencies repeat as appropriate. So we could look at the header and study all that. Yeah, so maybe we do even have the spectrum data. That'd be cool.
Well, yeah, you got the calibration data, the calibration info, the spectrum data. You've got it all plotted out here. You can download the FITS files, convert the FITS files, pull the data, extract it from the FITS files, and everything. So
the other thing, of course, here is a standard FITS file. Maybe I can output Ezra stuff in this format, using this as a guide. Again, I say FITS could have so many different formats and tweaks, which makes it flexible, but I don't know which one to use. Thank you. This is neat. I was having trouble getting the data. I can see this page, but how do we actually get to the data, to the numbers? Like you showed me a table.
there are actually links at the top of these for each of these observations.
And yet underneath that box, it talks about raw data at some place on pork. I don't know what that means.
Yeah, so that's just the raw data. That's actually the first table that I showed you right there.
Okay, well, maybe that's what I need. Yeah,
And so
great.
that's,
There were so many buttons I didn't push that one. Thank you.
yeah, there's quite a bit there. So it's been fun to play around with it. So that's about it.
So Rich, Sarah might have to get more money into that account if we get this excited. Lots of people. Well, actually, they could pull old data. Let's do that first.
Rich is muted.
All right, I did it to myself. Okay, so let's talk about that. Nathan, great work. The we have renewed our contract with them. We have put more money in, and trust me, if we rarely use all the account time we've got with them, and I'm glad to see Nathan jumping in there and using it. The other new information on that is that they have lifted the restriction of foreign nationals using the account. So if you since we're not sort of an international organization, if you're from Germany or if you're not U.S. citizen, you can now jump in and use the account, which is new because before it was only U.S. citizens because they were doing the way they were funded. But now I think that that's lifted. So if you want to get a password to the 20-meter telescope, which I advise everybody, if you haven't played with it, go do it. Go ahead and do that because you pulsars, magnetars, you can do all sorts of stuff with that. Anyway, any question on that? See Steve Zekas. Send an email to Steve Zekas and he'll hook you up.
Now I'm hoping that Nathan will step out of the side because we need to see your background, sir. We got an antenna out there that's enjoying the weather. So you built your own antenna there as well. And I think I've seen some of that data. Hold back just a little bit farther. Neat. I just took a screen picture. That's all. Thanks.
Did I send you some type of a user's guide for the GB20, which I haven't been able to find right now?
I don't remember.
Well, we've got a couple YouTube videos on that, and
I sent you. It was just like a Word document or something.
Alex, we published your slide set on the 20-meter in a couple journals ago.
Okay.
So look in my index and see which journal it was, and then find it.
Okay. I don't know if there's anything in there that would be useful to you or not, Nathan.
Well, yeah. Also on the Sarah webpage, there's also the 20-meter pulsar observation program, and there's links in there to the presentations and the video, so it tells you how to use it and everything.
Right. And
Nathan, you were showing us that nice picture of the data you were playing with. We hope you can put that link in the chat.
Sure thing.
All right. And by the way, you don't need an account to get the link data. It's all open source. So you just need the account to do your own observations. And but otherwise, they've got years and years of data from people who've already done the observations, and you can just pull their data up for free. I mean, and anybody can do it. So go ahead and look at that. Okay, any questions for Nathan? Great work, Nathan. This is good stuff. All right, Richard Flagg, do I still got you yet? I keep calling to you because I keep seeing your maybe not. Oh, I'm just trying to get him online here. Okay.
Richard, you seem to be unmuted, but we don't hear any voice.
Oh, really?
I see Richard waving at us, moving the camera, but no voice. At least a wave. He's friendly. That's good.
I hear a voice.
I can hear. I mean, am I on, guys? Anybody can hear me?
Yep.
Anybody else?
Richard, you're coming through fine. We just don't hear Rich Russell. I'm sorry, we don't hear Richard Flagg.
Oh,
I'm trying.
There you go. Okay,
There you
we got
go.
you, Richard. Go ahead.
Finally. Well, it turns out you have to plug the microphone USB connector all the way in. I had some thoughts regarding the Jupiter question earlier. The fact that he has a 40 kilokelvin background temperature is good. It's normally in the range of 30 to 70 kilokelvin. The terminated folded dipole should work fine. He should see about a 10 dB increase between the antenna disconnected and connected. And I would really recommend against using a preamplifier, which will overload the Jove receiver, the RJ1, and probably overload the SDR Play receiver also. Shouldn't need them. The coax run from the antenna to the receiver should not be greater than, say, 5 or 6 dB of loss. But that, generally is not a problem. So anyway, those were some of my thoughts concerning the questions about the Jove setup. Over.
Yeah, I heard you. And I had a question. I think one of his issues was converting the kilokelvin to dB. Was there a simple model for that? Because I think he's got the temperature on the vertical, and he probably doesn't have a dB indicator. Is there a conversion for that?
Well, the temperature is really the right way to go, and dB is a relative comparison between two levels. So basically the 40 kilokelvin is his baseline noise floor. The Jove receiver itself has about 1,000 degree noise temperature, and the galactic background is really what sets the noise floor, because it's 40,000 or so degrees Kelvin. So you generally don't have to worry too much about the receiver noise floor, which is why I would recommend not to use a preamplifier in order to get a lower noise temperature, because the receiver is usually not the main factor. It's the galactic background itself. When you go up to higher frequencies like hydrogen, the sky temperature is 10, 20 degrees Kelvin. But at HF, where we're listening to Jupiter, it's 40 or 50,000 degrees. So the game is a bit different at the lower frequencies, where you fortunately don't have to worry as much about the receiver noise temperature. You can be a little bit sloppier down there, which is good.
The preamp arose because he was not seeing, or I don't think he saw, at least 10 dB delta between antenna and no antenna.
Well, if he doesn't, he's got too much coax loss, I would guess, because we've used the terminated folded dipoles with considerable success.
But they're not going to be an improvement.
I don't think it'll be an improvement. Like you pointed out, you're getting more bandwidth with the terminated folded dipole. Yep.
The terminated folded dipole is really a gimmick, and he'd be better off doing fan dipoles for more bandwidth.
I'm sure those would work too if you've got the space for it. Yeah. That's also a good idea. Over.
All right. Great. Did you guys see the X flares on the Radio Jupiters?
Some of the guys were on and did, and hadn't lost data for some reason.
Oh. Okay. All right.
Thanks,
all right. Any questions for Richard Flagg? All right.
Good. Got off easy.
Tom, are you on? And you got any words about your grant program?
Let's see. I can't get the camera to work, but I can get the microphone to work. I'm pretty happy. We've got 2 grants underway in the States, which is something new. They're both for Radio Jove. There's another gentleman, a student, that was looking for Radio Jove, and I told him that would go ahead and, for him to apply for a grant, and we'll get it for him. Rich, can you hear me?
I can. Go ahead.
Okay.
Keep going.
All right. So that's what's going on. Last weekend, Hamfest, which is done by the Gwinnett Amateur Radio Society. We were there with Sarah, and I'm working with a student who is going to image the galaxy in neutral hydrogen. So we had her project there, and that was well received. So Sarah got a little bit of publicity.
Excellent.
I guess that's all I've got.
Well, great. And for everybody that's on, I think every science fair project that has used radio astronomy has gone very high in the science fair program at whatever level. People just think it's really cool stuff, and not many kids are doing it. So if you guys have any science fair students you want to mentor, we can do that. We could probably get them a grant to do a science fair project and get their teachers online with it. Okay, thanks, Tom. I think Mike, you're Mike Ott. I think you're the last one. Well, I keep losing people. Okay. Anybody I didn't get, or anybody have any new stuff?
I want to show you the NASA FITS viewer.
Go ahead.
Just a second. I posted it in chat, but let me show you what it looks like. If you're not familiar with it, I posted the link. Hopefully you can see it. And take a look at this software. It allows you to pull in the same photos from the GD20 and has the ability of plotting it in different formats.
Nice. All right. Any more questions for Alex or anybody else?
Yeah, this is Ed. I was searching the thing for the PSIrotator software. I got that. But what about the actual 6500 AZL rotator?
5500.
5500. Okay. Yeah, that's the Yaesu then.
Yes.
Okay. That will be easy to dig up. Thank you.
Maybe Rich. No, Rich, you're back.
I mean, I just lost internet for 2 minutes. Wow.
We
Okay.
saw you freeze up. Okay, good. It's back to you, Rich.
I missed what Ed's question was, but if you guys got it, that's fine.
Yeah, it looks like it was the Yaesu 5500 rotator that,
yes.
that you were citing. Yes. Okay.
Okay, great. That's one I saw, but the PSIrotator sounds like that's a good option that might be already linked to.
No, the PST is just software.
Oh, it's software. Okay.
Yeah. It's control software.
Yeah. And my experience with AMSAT with the 5500 is that you have to buy a $600 converter box that goes from the computer to the G5500, and that was very painful. So I ended up making my own Arduino version of that. So that's the reason that people are trying to do something different than the very expensive converter box.
Yeah, it's true. There are some other converter boxes that are a little less. Fox Delta, I think, has something at about $100. But what I've been trying to do is the 5500D is a DC drive motor and a pot, basically. And there's no darn reason to have that huge box and everything there. Your Arduino can control that thing directly. In other words, don't need the box with the dials and the calibrators and everything. It can all be done in software, but nobody's done it. And you can't, and the other thing is you can't buy the 5500D head, okay? Just the head with a couple of connectors. And that would just be outstanding. I don't understand Yason sometimes. They drive me crazy. But you can't just buy the motor and the positioners. But if you could, a simple Arduino would drive that motor and that because it's just a little motor because it's geared down so far. You could drive do the motor and the pot. 10 bits on the pot is about what you could get, right? You can get that right on the Arduino itself, or a ESP32, or any other little $4 chip nowadays, and you don't need anything else. So I just drives me a little bit nuts. But on the other hand, if you can get it into PSIrotator, which does have an interface for RS-232, and may have an interface for A to D conversion. I don't know, some A to D converter of some kind. That's the software to have for the controller. You get satellite, you get celestial. As I say, you get an easy hookup to all of Jim Sky's programs, etc.
Okay.
Sorry
All
to
right.
vent like that, but it's one of my favorite hates. One of my favorite stupidities.
So I
All
put links in the chat to PSIrotator and to the Yaesu site with the G5500 on it.
Great. Okay. Last call before we go off. Anybody got anything else?
G5500 D, I think it is.
Yeah.
Yeah. DC, actually.
Yeah, it's the DC version. That's what you want. It's the latest one.
Okay.
I have just one more thing to show off because Ted asked me to bring it up. Let me see if I can do a screen share here. This is again still less than 24 hours of data because I just started this yesterday, but I did a little bit of processing on it, and it's fun to see that we're getting some hydrogen readings here right in line with what we would expect for the galactic plane. So we thought that was just fun to see it looking this good so early, and now it's just a matter of me giving it some time out there to get like a more full amount of data. But I just thought it was cool to see it working this well so soon, right after us just getting it running yesterday.
That's great. That's
and
great.
I don't know, Ted, if you have any additional comments, because again, this is all practically still Greek to me, but I can at least tell that it's showing up. Like the readings are showing up where we would expect the readings to show up, which is a good first sign.
And I think that's pretty good for us to kind of guessing at 45 degrees. So you can get that inclinometer, the fancy little protractor out there, to tell us what angle your telescope is really at.
Yeah,
And
when it's a little bit less
then that'll
muddy
work.
and I won't be ruining a second pair of shoes, I'll go out and plunk that on there.
His backyard was a bit muddy yesterday, yes. But so it's fun to get the first results. Here we go.
Yeah.
Thanks.
Cool. You're
Excellent,
welcome.
guys. And the and great segue for our next Zoom call is going to be Drake's Lounge Australia, which is this Friday for US, Saturday morning for Australia. And the reason it's a segue is because that southern part of your map, your chart there, your lower inclination or declinations is being provided by the Australia groups for us. And Ted, I think you've got a pretty good group down there that's been giving you data, but we should be able to fill in the entire celestial chart here pretty soon.
Well, that's what we hope to. Everyone's learning at this point, and I think that's part of the process. It just has to happen as well.
Right. So I'll send out the notice to everybody about Drake's Lounge Australia. Those guys are a fun group. They've got a big antenna down there, and a lot of people doing solar, magnetometer, radio Jove, all sorts of things down there. So great talk we have with those guys every once a month. All right, that's all I've got for today. Thank you, everybody, and keep plugging. And get on listserv if you're going to 24 hours of perpetual help. You need
Thanks,
it.
Rich. Thank you.
Thanks, everybody.
Thanks, Rich. Thanks, everyone. Bye.
Take it easy. Take it easy, everyone.
Cheers, Rich.
Thanks, guys.
Bye.